Okay, so today we're going to be looking at parallel and perpendicular lines. So we either did the investigation already or we didn't have time to. So you're going to go to page 11 in your notes packet. So parallel lines are lines that never intersect. This means that their slopes are equal or the same. Perpendicular lines are lines that intersect at right angles. Their slopes are opposite reciprocals. So when you hear opposite reciprocals, what you should think is change the sign and flip the fraction. So for example, if you have the number 3, the opposite reciprocal of that would be to change the sign, so it would become negative, and flip the fraction. Well, if you're thinking, well, 3 isn't a fraction, right? We can always make a fraction by putting a whole number over 1. So flip that around. So the opposite reciprocal of 3 is negative 1 over 3. So the opposite reciprocal of negative 4/7 is positive 7 over 4. I changed the sign and flipped the fraction. The most important thing about these is you need to pay attention to what it's asking, right? If it's saying parallel, think same. Perpendicular, think opposite reciprocals, and neither, right, would be it's neither of these cases. If we want to determine whether graphs are parallel, perpendicular, or neither, you need to get them in slope-intercept form because it's all based on their slopes. So like if you look at A, line 1 is y equals negative 2x. That's in slope-intercept form already, right? Even though we don't see a B, that just means that the y-intercept must have been 0. But line 2, that's not in slope-intercept form. So my first step is to get that in slope-intercept form. And remember, slope-intercept form is y equals mx plus b. This way we can easily see the slope. So to get the y alone, I'm going to minus 2x. So I have y equals negative 2x plus 3. So all I do is I look at their slopes. This has a slope of negative 2. Excuse me. This has a slope of negative 2. Since their slopes are the same, they're parallel. And that's it. That's what you're checking. So if I look at over here for B, neither of these are in slope-intercept form. So line 1, I'd have to add 3x. So I have 4y equals 3x plus 8. Then I have to divide by 4 to get the y alone. So I have y equals 3/4 x plus 2. Over here, I would have to add 4x. So I have 3y equals 4x minus 6. And then I divide by 3. So I have y equals 4/3 x minus 2. Now, in these cases, the y-intercept doesn't matter. It's all based on the slope. So 4/3 and 3/4. They're not the same, so these lines aren't parallel. Perpendicular, they need to be opposite reciprocals. These are reciprocals of each other, but they have the same sign. So they are not opposite reciprocals. So they're not perpendicular either. So this would be a neither. So let's look at C. So this one, right, I subtract 3x. I have 5y equals negative 3x plus 10. Divide by 5. I have y equals negative 3/5 x plus 2. Over here, I'm going to minus 5x. I have negative 3y equals negative 5x minus 6. Divide by negative 3 on both sides. So I have y equals 5/3 x, positive 5/3, two negatives make a positive, and negative 6 divided by negative 3 is positive 2. So I look at my slopes, negative 3/5 and positive 5/3. They're not parallel because they're not the same. Over here, notice that it's the fraction flipped, so they're reciprocals of each other, and they have opposite signs. So these are opposite reciprocals, so they are perpendicular. Last one. So over here, I'm going to minus 2x. So I have 7y equals negative 2x minus 35. Divide by 7. So I have y equals negative 2/7 x minus 5. Here I'm going to minus 4x. I have 14y equals negative 4x minus 42. That should be 42. I know that looks weird. Divide by 14. So I have y equals negative 4 over 14 simplifies to negative 2/7 x, and 42 divided by 14 is negative 3. So I look at the slopes, negative 2/7 and negative 2/7, that's definitely the same slope, so these are parallel. Notice that if I wouldn't have simplified, I wouldn't have seen that they were the same. So you always want to reduce your fractions as much as possible. So that's if you have lines already, if you want to see if they're parallel, perpendicular, or neither. If we're writing equations of lines, so this one says write the equation in slope-intercept form for the line that's parallel to the given line and has the given y-intercept. So what it's saying is the line that I want to write the equation of is parallel to this line. Well, I know that parallel lines have the same slope. Well, the slope of this line is 1/3, so the slope of my line is also 1/3. It's also telling me that the y-intercept of my line is negative 3. Since I am given a slope and an intercept, I can write it in slope-intercept form right away. Y equals 1/3 x minus 3. There's my solution. Now B, my line is parallel to this line, so they should have the same slope. I can't tell what the slope of this line is because it's not in slope-intercept form. So the first thing I have to do is solve this equation for y. So I have to subtract 6x. So I have 2y equals negative 6x plus 2. Divide by 2. And I have y equals negative 3x plus 1. So since the slope of this line is negative 3, the slope of my line is negative 3. That's all you get from this equation is the slope. The y-intercept of my line is 8. So I have a slope and a y-intercept. I can write it in slope-intercept form. So it's y equals negative 3x plus 8. There's my solution. So let's look at the next set of examples. This one, write an equation of a line in slope-intercept form for the line that passes through the given point and is parallel. So this is the same exact thing we just did, except instead of giving you a y-intercept, they give you a point. So we have to put it in point-slope form first. So since it's parallel lines, I know that parallel lines have the same slope. So all I do is take the slope from the equation that they give me. So it's negative 1/2. That's all I use this equation for. My line's parallel to this one, so I know they have the same slope. Then I know that my line passes through this point. So I write it in point-slope form. Y minus 3 equals negative 1/2 times x minus negative 2. Now, always look for the final form they want it in. They want it in slope-intercept form, so I have to solve for y. So first, minus negative 2 is plus 2. I need to distribute. So I have y minus 3 equals negative 1/2 x minus 1. Negative 1/2 times 2 is negative 1. Then I add 3 to both sides. So I get y equals negative 1/2 x. Negative 1 plus 3 is positive 2. There's my equation in slope-intercept form. This one, same idea, but before I can even solve or get the slope, right, I need to solve for y. So I'm going to minus 3x. I have negative 4y equals negative 3x minus 2. Divide by negative 4. So I have y equals, this becomes positive 3/4 x, and negative 2 divided by negative 4 is positive 1/2. Don't freak out about the fractions, right? All we're getting from here is our slope. The slope of my line is 3/4 because it's parallel. Then I have this point, so I put it in point slope form. So I have y minus 6 equals 3/4 times x minus 3. Because I want my final answer in slope-intercept form, I have to distribute the 3/4. So y minus 6 equals 3/4 x minus, so 3/4 times 3 is 9/4. Now to get the y alone, I add 6. Again, if you have trouble adding fractions, that's okay. Use a calculator to help you. But negative 9/4 plus 6, I would need to change the 6 so it had a denominator of 4. So it would be 24/4. Because 24 divided by 4 is 6. So negative 9 plus 24 is 15. So this is plus 15/4. And there's my answer. Right? Even when you have fractions, the process is still the same. So let's look at another example. This one says write the equation in slope-intercept form for the line that is perpendicular to the given line. So perpendicular, you have to be careful. Perpendicular does not mean same slope, right? It means opposite reciprocals. So if the slope of this line is positive 2/3, the slope of my line has to be negative, and I have to flip the fraction. So it's negative 3/2. Once I find the slope, it's just like parallel lines. I have the slope. I don't use this equation for anything else. My y-intercept, they're telling me, is 1, so I can write it in slope-intercept form right away. Y equals negative 3/2 x plus 1. If I look at b, first thing I need to do is get the y alone so I can find out the slope. So minus 5x. I have negative y equals negative 5x minus 3. Divide by negative 1. I get y equals 5x plus 3. So now, since the slope of this line is 5, and my line is perpendicular to that, since it's a positive 5, I change the sign so it becomes negative. Then I flip the fraction. Remember, 5 is like 5 over 1. So when I flip the fraction, it becomes 1 over 5. So my slope is negative 1/5. My y-intercept is negative 6. So y equals negative 1/5 x minus 6. And there's my equation. So if we go to the next example, same exact thing we did with parallel lines, but it says perpendicular instead. Right? So this equation gives me the slope of the line. My line is perpendicular to it, so I need an opposite reciprocal slope. So since that was positive 1/3, I need negative, and I flip the fraction. It's negative 3 over 1, or just negative 3. Gives me a point, so I need to write it in point slope form. Y minus 5 equals negative 3 times x minus negative 4. minus negative makes plus positive. It's asking for my final equation to be slope-intercept form, so I have to solve for y. Distribute. So I have negative 3x minus 12. Then I get the y alone by adding 5. So y equals negative 3x minus 7. So this one I got to solve for y first. So I have 3y equals negative 2x plus 12. Divide by 3. I have y equals negative 2/3 x plus 4. So in this case, again, my line's perpendicular, so I need opposite reciprocal slope. So since it is negative, my slope is positive. Since it was 2/3, I flip the fraction, it becomes 3/2. So my slope is positive 3/2. Here's my point. So I'm going to write it in point slope form. Y minus 6 equals 3/2 times x minus negative 4. Minus the negative makes plus a positive. And now I'm ready to distribute because I want my answer to be solved for y. So 3/2 times x is 3/2 x. 3/2 times 4 comes out to be a nice number. 3 times 4 is 12 divided by 2, so it's 6. So now to get the y alone, I add 6 to both sides. So y equals 3/2 x plus 12. There's the answer. There's my equation of my line. Now, example 6. This one says scientists excavating a dinosaur map the site on a coordinate plane. If one bone lies from negative 5/8 to 10, -1, and a second bone lies from -10, -3 to -5, -6, do the bones lie parallel to one another? Explain. This isn't asking us to write the equation of the line, it's just asking us to see if it's parallel. Remember, we know it's parallel if they have equal slopes. So I'm going to take the coordinates of the first bone and find the slope. We find the slope, right, by y2 minus y1 over x2 minus x1. So, if I follow that, it's -1 minus 8 over 10 minus -5. -1 minus 8 is -9. 10 plus 5 is 15. Then I'm going to take the second bone and find the slope for that. So this one, it's -6 minus -3 over -5 minus -10. So these become pluses. -6 plus 3 is -3. -5 plus 10 is +5. So I have -9/15, -3 over 5ths, or 3 over 5. Now what I want to make sure, right, is that this doesn't simplify. Well, both 9 and 15 are divisible by 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. Oh, look, now they are the same. So they are parallel because they have the same slope. So, if I look at the next one, in the ruins of an ancient civilization, an archaeologist found pottery at 2, 6 and hair accessories at 4, -1. A pole is found with one end at 7:10 and the other end at 14:12. Is the pole perpendicular to the line formed by the pottery and the hair accessories? Explain. So again, perpendicular means opposite reciprocals. So I have to find the slopes first. So I look at the slope of these 2 points, or the line formed by those 2 points. So y2, so -1, minus y1, so -6, over x2, so 4, minus x1, so 2. -1 minus 6 is -7. 4 minus 2 is 2, and that doesn't simplify. So now I'm going to look at the pole and find the slope of that. So again, y2 minus y1, so 12 minus 10, over 14 minus 7. 12 minus 10 is 2, 14 minus 7 is 7. So now I look. They have opposite signs, and notice they're reciprocals of each other. 7 over 2 versus 2 over 7. So these are perpendicular. And why? Because they have opposite reciprocal slopes. Last one. Oop. Okay, for some reason I don't have it on here, but that's okay. It says an archaeologist is comparing the location of a jeweled box she found to the location of a brick wall. The wall can be represented by the equation, and let me write this down since I don't have it on here. By the equation y equals negative 5/3 x plus 13. It says the box is located at the point 10, 9. Write an equation representing a line that is perpendicular to the wall and that passes through the location of the box. So even though this is in word problem format, it's still the same thing. We're looking at perpendicular lines, and that's the symbol for perpendicular. So I take the slope of the line I'm given, and I want the opposite reciprocal of that. So it was negative, so it becomes positive, and I flip the fraction. So it's 3/5. And I want to make sure my line passes through the given point. So I have a slope, I have a point, I write it in point slope form. Y minus 9 equals 3/5 times x minus 10. Now it says to write an equation of a line. It doesn't state whether or not to put it in slope-intercept form. If it doesn't tell you, you always do. So I distribute 3/5 times x is 3/5 x. 3/5 times negative 10 is negative 6. 3 times 10 is 30, divided by 5 is 6. That's where it comes from. Then I add 9, and I get y equals 3/5 x plus 3. So that is the equation of the line that's perpendicular to the wall and that passes through the location of the box. So again, this is the third word problem that for some reason didn't come out on my note sheet. All right, we're all done for today. I'll see you guys tomorrow. Make sure you fill out the Google form below there.